Intriguing minerals. The planet houses various minerals like silicate rock and compounds like sulfur, giving it a unique and colorful terrain. You won't be breathing easy there. Scorching surface. With daytime temperatures reaching a scorching 800 degrees Fahrenheit, 430 degrees Celsius, and freezing nights, it's a planet of extremes. Impact craters. Galore. Mercury's surface is pockmarked with impact craters from asteroids and comets, creating an otherworldly landscape. Mercury, our solar system's smallest planet, is a celestial enigma. Core of iron. Mercury boasts a massive iron core, making up about 60% of its composition. That's like having a giant metallic heart at its center. Thin atmosphere. Unlike Earth, Mercury's atmosphere is super thin, primarily made of oxygen, sodium, and hydrogen.
Ever wondered what makes Venus so unique in our solar system? Let's take a closer look at Venus's composition. Venus is often called Earth's sister planet because of its similar size, but it's anything but Earth-like when it comes to composition. Venus is a scorching hot world with a thick atmosphere primarily made up of carbon dioxide. This extreme greenhouse effect traps heat, making Venus the hottest planet in our solar system. Beneath the thick clouds, Venus has a rocky surface featuring vast volcanic plains and highland regions. The surface is dotted with thousands of volcanoes, some of which are still active today, but what's even more intriguing is Venus's geological diversity. It boasts unique structures like massive mountain ranges, lava plains, and even mysterious tesserae, or tile-like, terrains that scientists are still trying to understand.
Earth is like a giant cosmic layer cake with three main layers: the crust, mantle, and core. The crust is like Earth's outer skin, where all the action happens, including continents, oceans, and of course, humans. Beneath the crust, we have the mantle, a semi-solid layer of rock that flows over geological timescales. Finally, at
Mars, the fourth planet from the Sun in our solar system, has a unique composition that sets it apart from the other planets. Here's a brief overview of Mars' composition. Atmosphere. Mars has a thin atmosphere composed primarily of carbon dioxide, about 95.3%, with trace amounts of nitrogen, argon, and other gases. The thin atmosphere contributes to the planet's cold surface temperatures and limited ability to retain heat. Surface. The Martian surface is rocky and marked by vast plains, canyons, and volcanoes. The prominent iron oxide, or rust, gives Mars its reddish appearance. The planet's surface also contains various minerals, including basalt, which is a volcanic rock commonly found on Earth. Polar ice caps. Mars has polar ice caps composed of water and carbon dioxide. These caps undergo seasonal changes, expanding and contracting. Jupiter, the largest planet in our solar system, is a gas giant composed primarily of hydrogen and helium. These two elements make up about 99% of its total mass. The planet's composition is quite different from the rocky planets like Earth, as Jupiter lacks a solid surface. In Jupiter's outer layers, the intense gravitational pressure and heat cause hydrogen to behave in a unique way. The planet's interior is thought to consist of a dense core, possibly composed of heavy elements like rock and metal, surrounded by layers of metallic hydrogen. Metallic hydrogen is a state of hydrogen where it behaves like a metal due to extreme pressure, allowing for electrical conductivity. Jupiter's atmosphere, which is the visible outer layer, is made up of clouds of ammonia and methane, as well as other trace elements. These clouds create the distinctive bands and zones seen in Jupiter's atmosphere. The planet also exhibits a series of swirling storms, most notably the Great Red Spot, a massive storm system that has been observed for centuries. Saturn, the sixth planet from the Sun in our solar system, is a gas giant with a captivating composition. Unlike the rocky planets such as Earth, Saturn lacks a solid surface, and its outer appearance is dominated by thick layers of gas. Here's a brief overview of Saturn's composition. 1. Atmosphere. Saturn's atmosphere is primarily composed of hydrogen and helium, with trace amounts of methane, ammonia, water vapor, and other hydrocarbons. The swirling bands of clouds and storms visible on the planet's surface are formed from these atmospheric gases. 2. Core. Beneath its gaseous outer layers, Saturn is believed to have a small, rocky core. This core is enveloped by layers of metallic hydrogen, a state of hydrogen that behaves like a metal due to the immense pressure at Saturn's core. 3. Rings. Saturn is renowned for its stunning ring system, which is composed of countless icy particles ranging in size from tiny grains to large chunks. These rings are predominantly made of water ice, along with smaller amounts of rocky material and organic compounds. Uranus, the seventh planet from the Sun in our solar system, is a gas giant with a composition that distinguishes it from its neighboring planets. The planet's composition is primarily composed of hydrogen and helium, much like Jupiter and Saturn. However, what sets Uranus apart is the presence of significant amounts of ices, such as water, ammonia, and methane. The outer atmosphere of Uranus consists mainly of hydrogen and helium, while the inner layers contain a mixture of ices and rock. The icy components give Uranus a bluish-green hue, as they absorb red light and reflect blue and green wavelengths. The exact proportions of these ices remain uncertain, but water ice, ammonia ice, and methane ice are believed to make up a substantial part of Uranus's composition. Neptune is primarily composed of hydrogen and helium, similar to its gas giant counterpart, Jupiter. These two elements make up the majority of the planet's mass. However, unlike Jupiter, Neptune has a higher proportion of ices such as water, ammonia, and methane. These ices are found in the form of clouds in the planet's atmosphere. Beneath its thick atmosphere, Neptune is believed to have a layer of fluid hydrogen and helium surrounding a rocky core. This core is thought to be composed of metals and silicates, giving Neptune a solid central structure. The exact nature and size of Neptune's core remain subjects of scientific investigation, as it is challenging to observe and study the interior of a distant gas giant. Neptune's atmosphere is characterized by dynamic weather patterns, including powerful storms and the fastest winds in the solar system. The presence of methane in the atmosphere gives Neptune its distinctive blue color, as methane absorbs red light and reflects blue.